Welcome to the world of computer networks. In this video we will talk about the checksum technique, so let's start with the outcome. Upon the end of this session you will be able to know the types of error detection techniques and understand the checksum technique and its performance. We have seen in a previous video that there are basically three types of error detection techniques that are used in data communications and in a link layer especially: the parity check, the checksum, and the cyclic redundancy check or CRC. So let's focus on the checksum in this session. In this error detection scheme, we will see what happens in both sides, at the sender and the receiver side. The following procedure is applied at the sender side. First, the data is divided into fixed sized frames or blocks. Then we sum all of the data blocks with adding the carry to the sum if any carry is generated. And finally, we use the ones complement to the resulting sum to get the checksum. At the receiving side, the following steps are followed. We sum all the received data blocks including the checksum block and we check the result. If it's all ones, we accept the data, else the data is rejected. So let's understand the checksum operation with an example. We consider the following data to be transmitted. So here we have the data that we want to transmit to a receiver. The first step for the sender is to break the message into blocks. So here we will break the message into 3 blocks, each of 8 bits. Now let's see what the sender does with these 3 blocks. The second step is to perform the binary addition of all blocks. So we take the 3 blocks and we perform binary addition. So here we have 0 plus 1 plus 0 is a 1, 0 plus 0 plus 1 is a 1, 1 plus 1 plus 0 is 1, 0, so we put the 0 here and we have a carry. So we continue like that until the end. If we have a final carry, we perform another addition until no carry is generated. So we take the carry and we perform another addition. The same way we have the result. When we get the final sum, we perform the ones complement. It simply consists of changing the ones by zeros and zeros by ones. With this step, we are done and we have our checksum. So what the sender does with this checksum, he appends the checksum or this generated block to the original message and send all the data to the receiver. Let's assume that the receiver is receiving the data block without errors. So the first step is to perform addition of all blocks received, including the checksum. Again, we perform the binary addition, but this time we will do it with all blocks, including the checksum. If a carry is generated, we do the addition again until no more carry is created. At the end, we have a result, so we check the result. If all the bits in the result are ones, the receiver accepts the data. Of course, any other result leads to the rejection of the data block. So the checksum is a very powerful technique because it can detect all errors involving an odd number of bits. It can also detect most errors involving an even number of bits. The only drawback is when we have errors involving no change in the summation. When there is no change in the final sum, the checksum technique will not detect the errors. That is, guys, thanks for watching and see you in another video.